essence of a man like me lies just in what he thinks and how he thinks, not in what he does or suffers.
Thanks to your not being a scientist, we're all going to have to give this account the simplicity that Einstein would have loved.
Would it be really possible for this to happen?
Perhaps we should start with the simplest point of all.
The most beautiful thing that we can experience is the mysterious. It's the only source of true art and science. You silly boy. It was one of Einstein's earliest ideas in relativity that you could distort time and space just by traveling fast enough. We now left gravity and general relativity aside for a while to hear instead about special relativity and the strange effects of motion.
Now let's imagine that these bikes are capable of, say, half the speed of light. That's what their speedometers show anyway, fractions of c, the speed of light. What kinds of Einsteinian effects can we illustrate with bikes like these?
Perhaps we should start with the simplest point of all. From the point of view of the rider, he's at rest, and it's the landscape that's rushing towards him. In Einstein's democratic universe, that point of view is just as valid as yours or mine. And then recall the Doppler effect, the change in frequency and color of light. An object rushing towards you looks blue because the light gets crowded together. It has a higher frequency. When it's going away, it looks red because the light gets stretched out, and then it has a lower frequency.
I'd like to emphasize something there, Peter. Compared with ordinary white light, blue light has a higher frequency and more energy too. But red light represents a low frequency and less energy.
Einstein made two important discoveries about the Doppler effect. First, it doesn't make any difference who's said to be moving. It's just the relative speed that counts. Einstein's second discovery about the Doppler effect is that when a high-speed vehicle is just passing you, strange things happen. Imagine that you were quick enough to photograph it with your camera. You ready, Peter? As the vehicle passes us by, you'd think it would be neither redshifted nor blue-shifted because it's moving perpendicular to our line of sight. But in fact, it's slightly redshifted. What's more, it's rotated away from us.
Not shortened? Many accounts of relativity would have the bike squeezed short.
No, it still appears to be undistorted, but slightly rotated away from us. But from the point of view of the rider, there could be very peculiar distortions of the scenery if you rode past buildings, say, almost at the speed of light. Perhaps the first thing you notice is the building and the truck curve in a little. Then, as you speed up, you see that they seem to be twisted towards you. Indeed, as your speed increases closer and closer to the speed of light, you start seeing the far sides of the building and truck. you seem to be seeing right around the corners. It's like walking through a rainstorm when your front gets wet and your back stays dry. The light approaches you from unexpected directions.
Consider two bicycles coming at each other at close to the speed of light. You might think that their combined speed, the rate at which they are coming together, is faster than light. But from each rider's point of view, it's not like that at all. Their combined speed, as they measure it, always remains less than the speed of light.
Einstein launched his disconcerting ideas from very simple premises. The riders demonstrated why time runs slowly in a fast-moving vehicle. They just rode in company and threw a ball to represent a signal, a flash of light. From their point of view, the light went straight across between them. But from our point of view, as onlookers watching the bikes go by, the signal went obliquely and on a longer path.
But light always moves at the same speed, so that the time it takes for the signal to go from there to here takes longer from our point of view than from the point of view of the riders. So Einstein tells us that their clocks in the moving frame move slower than ours in exactly proportion of this line to this line.
High-speed travel also makes you seem heavier. Time for a rapidly moving bike slows down and it accelerates more sluggishly. Mass means resistance to acceleration, and the bike's mass piles on as it gets near the speed of light. In fact, it continues to grow more massive without limit as it gets very close to the speed of light, so that in fact it never can go faster than light. But from the point of view of the rider, his mass seems the same as usual. When Einstein realized just how much the way things look depend on where you stand, he also saw a danger. Because, he reasoned, the laws of physics must be the same for the rider as for the fixed observer. Special relativity was born brilliantly out of that requirement, but the price Einstein exacted from us was the scrapping of the old ideas about time. Einstein realized that although each person's view of events is a little different, everyone's view is equally valid, and yet we are observing, all of us, the same laws of physics.
And the touchstone for the reliability of physical laws was Einstein's old obsession, the speed of light remaining constant amid all the commotion of the cosmos.
Now, because of its motion in orbit around the Sun, our Earth is traveling at a speed of about 30 kilometers a second. If the principle of relativity were not valid, we should expect the laws of nature to depend on the Earth's direction of motion at any moment. But the most careful observations have never revealed any lack of equivalence of different directions. This is a very powerful argument in favor of the principle of relativity.
But Einstein's revelations shook the planet. From the reasoning of special relativity emerged a law of creation and destruction. The most daring proposition in relativity is that the laws of nature must remain the same at all places and at all times, even in galaxies so far away that their light has traveled for thousands of millions of years to reach us. If so, Albert Einstein's own laws of nature, conceived with pen and paper on the planet Earth, hold good everywhere.
What really interests me is whether God had any choice in the creation of the world.